Hey guys, welcome back to another Vlesson. This is an especially special Vlesson because it is, drumroll please, the last Vlesson of the year for you. So it's the last new information. We are talking about radius chords. After this, you just have a review and then you have your assessment. So congratulations, you're almost there. Way to go. All right, let's do this. So on the left here, you see we've got chord AB. Again, a chord is a line segment with endpoints on the circle. If you visualize folding that chord onto itself, what do you notice about certain segments and certain arcs? Well, a couple of things are going to happen here. First of all, if you folded AB right on top of itself, it's going to cut minor arc AB in half. So these two parts are congruent. Second of all, it is also going to cut the line segment in half. So those two pieces are congruent. Third of all, this new chord that you created with the fold is actually going to be a diameter of the circle, right? Because you're folding the circle exactly in half. And since AB lies on top of itself, it is also going to be perpendicular. So this gives us a theorem. The theorem is if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. Which bisects, again, just to remind you, it means cut into two equal parts. So cuts in half. Okay, so it is perpendicular and it cuts it in half. So this helps us when we are trying to solve. First of all, if we look at this, we know CD is a diameter and it is perpendicular to chord AB. We know that AB, the full length, is 14, which since it is perpendicular, that means that the diameter of the CD diameter cuts the chord AB in half. So these two parts are congruent, which means that since the full length of the chord is 14, half of that would be 7. I don't know what happened there. Okay, so this part over here is 7, and this part over here is 7. So AM is 7, MB is 7. Now, we also know that the measure of arc AB is 144. So that's this full, that was ugly, but you get it. That full arc going around the circle. So if the full thing is 144, then the measure of arc CB would be half of that. So 144 divided by 2 is 72 degrees. And it would be the same thing for the measure of arc AC. So that's 72 degrees as well, because they would be congruent. So congruent. That's what those little tick mark means. Okay. Next, let's see here. Next, we've got kind of a similar situation, but kind of we're going the other way. So AM now I know is 11. And I am looking for what MB is. Well, AM, that's half of it. So MB is the other half of chord AB. So this would also be 11. And note, these are not tick marks here. These are actual, that's an 11. Okay. And again, if I know that the measure of arc AC is 50 degrees, what else can I find? Let's see here. Oh, I didn't answer AB. Sorry, guys, I skipped that one. Man, last Vlesson of the year, and I'm losing it. This AB would just be 2 times 11, or 22. Okay, so the measure of arc CB would also have to be 50, because you know it's cut in half, so 50 degrees. Measure of arc AB would be 50 plus 50, which is 100 degrees. Okay, so there's a relationship. As you look at these diagrams, you can kind of tell it looks like it's half. In this case, it actually is half, right? Like you're cutting the chord in half. You're cutting that arc in half. So in this case, it is. Okay, so now here, note, pictures are not drawn to scale. So get ready for this. Circle C has a radius of 5 centimeters and the length of chord QS is 8. Find the length of CR. So what I am looking for is this length right here. That's what I am trying to find. So let's see how we can find that. Well, I know that it's got a radius of 5. I know that QS is 8, and if QS is 8, and I know that these two parts of QS are congruent, they're going to be equal. So they're each half of 8, so this is 4, this is also 4. Now, I need to find the way that I can use the radius in this case is my radius is 5. What I'm going to do is I'm going to draw in radius QC. And I know that is 5 units long. Okay. And I am looking for the length of CR. So if I'm looking for the length of CR, I can label that as X. Okay. So I have a right triangle here. What I can do to find a missing piece of a right triangle is I can do Pythagorean theorem. X squared plus 4 squared equals my hypotenuse is 5 squared. All right. Solve this for X. X is equal to 3. This one is also a Pythagorean triple. So you should be familiar with that. Okay, so CR is what I was looking for. That is X. So CR is equal to 3. CR is just what I labeled as X. Okay, so this right here, this image on the right, that is from your formula chart. So if you're looking at your formula chart, you're like, where is this? That's what we're showing right over here. That's the relationship. All right, next, circle P has a diameter of 26 centimeters. The length of NP in the circle is 5. I'm going to go ahead and label that 5 right away. Okay, find the length of chord MO. So I am looking for this full chord. That's chord MO. Okay, so if I know the entire diameter is 26, that tells me that my radius is equal to 13 because I take the diameter, I cut it in half. Now I'm going to use that. Once again, I am going to draw in a line segment here. That is my radius, and that is 13. Okay, so now I'm not quite at the point where I can solve for MO. I am going to label X as just MN, just this portion right here, because I know that that length and the length next to it, the NO, are congruent. So if I find X, then I can multiply it by 2 and get my final answer. So let's set up Pythagorean theorem here. 5 squared plus X squared is equal to 13 squared. This is another Pythagorean triple, so you may just know it right off the top of your head, or you may need to solve using Pythagorean theorem. That's fine. Okay, so X is equal to 12, and then I have to multiply that by 2 to get the length of MO. So let's pick out a different color here. We'll go right. So MO is equal to the length of 2 times 12. MO is equal to 24. Okay, so far so good. Very nice. Next, given RE is equal to 15, so that's this portion right here, 15. DF is equal to 16. Once again, I'm just going to cut that in half because I know these two parts are congruent, right? So I'm going to say DE is 8, and I know that EF is also 8. I need to find the radius of the circle, so I'm going to go ahead and draw that in. Now I'm looking for this, X. Okay, so now I'm going to do 8 squared plus 15 squared equals X squared. Notice that when you guys are drawing in your radius into these right triangles, it is always going to be, the radius is always your hypotenuse. Okay, so that's just something to note if you're wondering how I'm setting up Pythagorean theorem. So now I can solve this using the Pythagorean theorem, or it is another Pythagorean triple. X is equal to 17, which means that is your radius, because that's what I labeled as X in the diagram. Next, ln is equal to 40. You guys already know the drill. I'm cutting it in half and labeling it in here. So this is 20, and this portion is also 20. mj, this portion right here, is equal to 21. Okay, I need to find the diameter of the circle. So this is going to be kind of a two-step process. First, I'm going to find the radius. Okay, I'm going to say 20 squared plus 20, 20 squared plus 21 squared is equal to x squared. Let me see, I don't know this one off the top of my head. Okay, so using Pythagorean theorem, I get x is equal to 29, and this would be the radius of your circle. But I don't want the radius of my circle. I want the diameter of my circle. So what do I need to do? Multiply it by 2. So 2 times 29 is equal to 58. So this right here, my friends, is your diameter. Great. So that is it. That is all I have for you today. That is the last of lesson. That's how we'll end it. All right. As always, if you guys have any questions, feel free to send me an email. Or if you're just bored and want to send me an email, feel free. Or if you just miss me because this is the last lesson of the year and you're realizing that you're not going to get to watch these all the time, feel free to email me. All right. Bye, folks. We'll talk to you soon via email.